This is the Math 2 lesson summary video for the lesson entitled, I've Gotta Fill In. In Lesson 9 of Unit 4, I've Gotta Fill In, the purpose of this lesson is to practice writing quadratic equations in equivalent forms using the knowledge we've learned from this entire unit. We will use our factoring knowledge, completing the square, and the distributive property. We will also use our knowledge from this entire unit to help us graph quadratic equations. In Lesson 9, I've Gotta Fill In, we are asked for each problem in this investigation. We're given a piece of information that tells us a lot about a quadratic function, and we're asked to use what we know about the information to fill in the rest. So we'll start by looking at number 1. Number 1's equation was y equals x squared minus x minus 12. We are asked to fill in the factored form of the equation. So recall that we do need to find two numbers that multiply to c and will add to the b value. So in this case, the b value is -1 and the c value is 12. Remember that when your a value is 1, or the number in front of x squared, this will always work. So two numbers that multiply to 12 and add to -1 are -4 and 3. Therefore, our factored form in this case would be y equals x minus 4 times x plus 3. So therefore, recall that we can find our solutions by setting each of our factors equal to 0 and solving. Therefore, our two solutions here would be x equals 4 and x equals -3. So our x-intercepts should be the points 4, 0 and -3, 0. That will be useful because we are now asked to graph the equation. So we will need to be able to plot these values on our coordinate grid. So let's just make sure that we can graph our x and our y axes. First, make sure like so. And then we'll fill in where our x-intercepts will be on our grid. So our 2 points are 4, 0 and -3, 0. Recall that our axis of symmetry will be the median of your x-intercepts, and that was from a previous lesson. So the middle value between +4 and -3 should be 1/2 or 0.5. Therefore, I know that when x equals 0.5, that is my axis of symmetry. We next need to figure out the vertex. So to figure out the vertex, we will plug in our x value for our axis of symmetry into the original equation, and we will solve that for y. When we simplify that, we do get y equals -12.25. So our vertex in this case should be the point 0.5, -12.25. So 0.5 will be on the axis of symmetry, and then we'll need to go down -12 1/4. Now that'll be off my grid, but I'm just going to estimate that's 2, 4, 6, 8, 9, 10, 11, 12, approximately down here. Okay, so now, and we also know that this c value, which is -12, will be our y-intercept, which will be somewhere up here. So let's just connect our parabola. A is positive, so we will be facing up. So number 1 is done. We have factored it and graphed it. The next question I'd like to look at together is number 3. Number 3, we're not given an equation. We're actually only given a graph. So we're asked to find the vertex form of the equation. Recall that the vertex form of a quadratic function is y equals a times the quantity x minus h squared plus k, where h and k is the center. H and k. The vertex. So let's look at this parabola, and the vertex is right here. So this is very hard to see, but this is a -2. This would then be a -3. So this vertex is at the point 2, -3. Recall that that's my h and my k in vertex form. Therefore, let's plug that in first. X minus 2 squared minus 3. make sure you guys can see that minus sign. So that is a minus. So x minus 2 squared minus 3. Now, to get the vertical stretch, remember that is the a value. We discussed in a previous lesson that we always go over 1 from the vertex and up to a. So when we're looking at a graph, we'll start at the vertex. So from the vertex, we're going to go over 1, and it's harder to see on this graph, but 3 is about right here, and up. The up is what we're looking at. So the up, in this case, it looks like, and it does look like it goes from -3 to -2. That would be up 1. So therefore, we have to set 2a equal to 1, divide by 2, and a would be 1/2. So your vertical stretch should be 1/2. And again, this graph is harder to see that, but it should be up 1. So let's see here. And that's 1/2. So now we're done with our vertex form. Our vertex form would be y equals 1/2 times the quantity x minus 2 squared minus 3. So to get standard form, we're going to take vertex form, and we're just going to FOIL that out or distribute that out. So x minus 2 times the quantity x minus 2 minus 3. Because recall that a quantity squared means that you're writing the quantity twice. So let's distribute our binomials. We're going to get 1/2 times the quantity x squared minus 4x plus 4 minus 3 on the end. Then we're going to distribute our 1/2 to everything in parentheses. We'll get 1/2 x squared minus 2x plus 2 minus 3. So let's now combine these like terms on the end, and our standard form would be y equals 1/2 x squared minus 2x minus 1. So we've now come up with the vertex form of the equation as well as the standard form of the equation. I'd now like to take a look at number 5. So number 5 again is giving us a quadratic function, but 5 is a little different than 1. Notice that the a value is negative. So in this case, the a is -1, the b is -6, and the c is positive 16. We are asked to give another form other than standard form in the first part. So let's factor this. Keep in mind if there is a negative outside, we should bring the negative and factor it out. So that would change all of our signs. We would have x squared plus 6x minus 16. So again, now that our a value is 1, we need two numbers that multiply to -16 and add to 6. So those two numbers would be 8 and -2. So x plus 8 times the quantity x minus 2, and this right here would be our factored form. We're then asked to come up with the vertex of the parabola. So if we know the x-intercepts, recall that between 8 and, that would be a -8. Remember that we set our factors equal to 0, and we solve to get our x-intercepts. So our x-intercepts would be -8 and positive 2. So we need to find what number is exactly in between -8 and 2, and that number will be -3. So we do know that in our vertex form, the h value will be negative times a negative will be plus 3 squared. So let's figure out what our k will be. To find our vertex, we can plug x back in. So y equals -3 squared minus 6 times -3 plus 16. And when we simplify that, we should get 25. So our vertex would be the point -3, positive 25. So therefore, this number on the end should be plus 25. Trying to figure out our vertical stretch, we can look at the graph, or we can just look at our a value. In this case, our a value is -1. We can write a -1, or we can just write a negative. So our vertex form here would be y equals negative times the quantity x plus 3 squared plus 25. We've already written out our x-intercepts. Our x-intercepts are -8, 0, and 2, 0. And to find our y-intercept, keep in mind, we would plug 0 in for x. So let's do that. Y equals negative 0 squared minus 6 times 0 plus 16. So y is 16. Also recall that the c value on the end of your quadratic function, as long as it's in standard form, will always be your y-intercept. So therefore my y-intercept is the coordinate point 0, 16. Let's try one more together. We'll look at number 6. So number 6 is given to us in standard form, except that the number in front of x squared, or the a value, is 2. So when we look at this, in order to factor, we would need to take out a GCF. But I notice that 13 is prime. Therefore, we cannot factor this. And that will be possible for some quadratic functions not to be factorable. So now let's discuss how to find the vertex of the parabola. Let's perform completing the square on this quadratic function in order to find the vertex. The first thing we'll do is we're going to put the 13 to the side. So we're going to work only with the 2x squared plus the 12x. We're going to take out our GCF of 2, and that 12 divided by 2 is 6, and we're going to complete the square. Recall that to complete the square, it's b divided by 2 squared. So 6 divided by 2 squared will give us our c value that's missing. And that missing c value should be 9. Now, if we look at this, 2 times 9 is actually 18. But we didn't want 18 little squares, we wanted 13. So we do have to subtract 5 on the end to make these two equations equivalent. Therefore, our vertex form should be y equals 2, and we're going to write this trinomial as a quantity squared, and that would be x plus 3 squared minus 5. And that's our vertex form. We notice that our vertex would be the point negative 3, negative 5 for this quadratic function. To find the x-intercepts for this function, since we could not factor it, let's use our graphing calculator. We could also use the quadratic formula, it is your choice. If we go to our graphing calculator, we're going to type our quadratic function into y1 and hit graph so that we can make sure we see the full parabola. To find our x-intercepts, we hit second, trace, and our x-intercepts are also called zeros. We're going to hit number 2. It's asking us left bound, which means we need to move our cursor to the left of an x-intercept and hit enter. When it says right bound, we're going to move our cursor to the right of the x-intercept, hit enter. It'll say guess, hit enter again. And an x-intercept will be the point approximately negative 4.58, 0. We're going to do the same thing because we do see another x-intercept, second, trace, number 2 zeros, and we're going to scroll to the right and go to the left of the other x-intercept. Hit enter. It does ask for right bound, so we're going to move our cursor to the right of the x-intercept, hit enter again when it says guess. So our other x-intercept will be the coordinate point negative 1.42, approximately 0. And again, you could use quadratic formula in order to solve for the x-intercepts as well. So let me just rewrite those here. Approximately negative 4.58, 0, and the point negative 1.44, 0. And for our y-intercept, recall that it's always the c value, so our y-intercept should be 0, 13. If you need more help on the Ready, Set, Go homework for this task, please check your Canvas student support site.